Square root functions. Our objective is to identify square root functions and their domains, as well as graph square root functions. Who uses this? Astronauts can use square root functions to calculate their speed in freefall. Let's look at freefall for a second. The function y equals 8 times the square root x gives the speed in feet per second of an object in freefall after falling x feet. This function is different from some of the other ones we've seen. It has a variable under the square root sign. When that happens, you have something that's called a square root function. So once again, a square root function has a variable under the square root. If the variable is not under a square root, it's not a square root function. So these examples all the way to the right are examples that are not square root functions. The ones in the middle here are all square root functions, because notice the variable is under the square root. So let's try a couple of examples regarding freefall. Find the speed of an object in freefall after it has fallen 4 feet. So we have our function for freefall, and then we're going to substitute 4 in for x. So we have 8 times the square root of 4. We know the square root of 4 is 2, and 8 times 2 is 16. Therefore, after an object has fallen 4 feet, its speed is 16 feet per second. Let's take a moment and try another one. Find the speed of an object in freefall after it has fallen 50 feet. So we have our y equals 8 times the square root of x. We're going to substitute 50 in for x. So we have 8 times the square root of 50. 50 is not a perfect square, so it's going to end up giving us a decimal. So when you put this into your calculator, you have 8 times the square root of 50, and you get about 56.6, and then feet per second. Now that we have the freefall piece, let's look at domain. So we're going to find the domain of each square root function. When trying to find the domain, we want to look at what's underneath the square root. Reason being is you don't want a value underneath the square root that's less than 0. Otherwise, you don't have a real number when you're done. So we're going to set what's underneath the square root, or the radical sign, to be greater than or equal to 0. So in this case, we have x plus 4 is greater than or equal to 0. And then we solve for x. So we subtract 4 from both sides, and we end up with x must be greater than or equal to -4. So the domain is the set of all real numbers greater than or equal to -4. Let's take a moment and try a few more. So once again, to find the domain, we want to take what's under the radical sign, or the square root symbol here, and we want to set that to be greater than or equal to 0, so that way we end up with a real number. So we have 3 times the quantity x minus 2, and this whole piece here has to be greater than or equal to 0. So you can do this one in a couple different ways. You can either distribute the 3 first, and then add and then divide, or we can divide by 3 since it's outside of the parentheses. So we're going to divide by 3 on both sides, which leaves us with x minus 2, and then we have is greater than or equal to 0. And then we can add the 2 to both sides. X must be greater than or equal to 2. If you distributed first, so we're going to put that off to the right here, you would have had 3x minus 6 is greater than or equal to 0. You would have added the 6 to both sides, and you would have had 3x is greater than or equal to 6, and then you would have divided by 3, giving you x must be greater than or equal to 2. So either way, you end up with the same result in the end. So now, take a moment, pause the video, and try C and D on your own. When you return to the video, the answer for both will be revealed. And there you have it. So now that we've looked at domain of square root functions, now let's move our focus to graphing square root functions. One thing that's very helpful when graphing square root functions is to know what the parent function is. The parent function for square root functions is f of x equals the square root of x. Remember, parent function is the most basic form. Notice how we're not adding or subtracting or multiplying anything with this square root of x. It's simply by itself with the square root. The graph of this function is going to look as follows. So you start at 0, 0, then you've got another point at 1, 1, and then you have another point at 4, 2. So we've looked at translations in the past. You can use the translations to help you figure out where your graph moves to. So when you add or subtract anything to this value here, you might be moving the graph left, right, up, or down. Sometimes the graph might get steeper or wider. So let's look at some of those. Translations of the graph f of x equals the square root of x. So when you're looking at f of x equals the square root of x plus c, so the value that's being added or subtracted is not underneath the square root, it's off to the side, it's outside of the square root, if you will. If it's outside, you're going to be moving your graph up or down. So if we have the square root of x plus 4, you're going to take this parent function and you're simply going to just move it up 4. From here, you're still kind of going up 1 over 1, up 2 over 4. So you're still following that same exact pattern as the parent function. You're simply going to just move it up 4. If you were adding 2, you would simply move the graph up 2. If you're subtracting 1, you're going to simply move the graph down 1. So now let's look at the graph of f of x equals the square root of x minus a, where it's all underneath the square root function. It's all underneath that square root. Just like with absolute value, when it's underneath or inside, you're going to move left and right. And because it's in the form of a minus, it helps to think backwards. Because if you were to rewrite our f of x function here, you would technically have the square root of x minus negative 4. This minus a negative is like adding a positive, hence the plus 4. So if you write it in the form that it's supposed to take to move things in a horizontal translation, you have to think backwards. So if it says plus 4, you're going to be going to the left 4. If it says minus 1, you're going to go to the right 1. Now let's put this to practice. So this first one is done out for us. So this one says that we have f of x equals the square root of x minus 4. It's already in the form of a minus, and it's all under the square root. So when it's under the square root, we're moving left or right. Now we just need to decide which direction we're actually moving in. So if it's a minus 4, we want to think backwards, so we're going to move to the right 4. Everything about the parent function stays the same other than it moving to the right 4. So you still have 1 point here, you're going up 1 over 1 to here, you're still going up 2 over 4 to here. So that part of your parent function is the same. You're just moving it to the right 4 to take into account this square root of x minus 4. But what happens when you have something that's being multiplied within this? So we have the square root of 2 times x, and then we're adding 3. When this happens, I suggest making an xy table, plotting those points, and then making your graph. So now let's pick a few values. Let's go with 0, 2, and 8. So when we plug 0 in, so we substitute 0 in for x, we have 2 times 0, which is 0. So the square root of 0 is simply 0. And then we add 3. So our y value is 3. This should make sense, because if we were to ignore this 2 for a second, and we were to have the square root of x, and then outside of that plus 3, your graph should technically move up 3. And it does. So we have that point at 0, 3. But when you multiply, it changes how fast the graph rises. So now let's plug in a 2. We have 2 times 2, which is 4. And then we have the square root of 4, which is 2. And then we're going to add 3 to that. So we end up with 5. Now let's do the same thing with 8. We have 2 times 8, which is 16. Take the square root of 16, which is 4. We're going to add 3 to that, which gives us 7. So we're going to plot a point at 8, 7, which is up here. And then we have that 2, 5. And then we sketch in our graph. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed. So for this one, you simply moved the parent function up 2. Nothing else happened. You weren't multiplying anything inside or outside of this function. So therefore, just move the parent function up 2, and you will have successfully graphed f of x equals the square root of x plus 2. So let's try one that's a little bit harder. I want you to take a moment, pause the video, and try this one on your own. When you return to the video, the answer will be revealed. And there you have it. So you might notice that I added a couple lines in here. It was so that way we could fit in this 9, 9, as the graph wasn't quite big enough to fit it in there. So I added a couple lines. So if you're multiplying on the outside, notice how quickly it increases. And when you multiply on the inside, notice how quickly it increases. So it changes it around a little bit. It doesn't quite follow a parent function that's simply moved up 2. Okay? So my suggestion is when you see something being multiplied when you're dealing with a square root function is to simply make a table and then plot your points. And that ends our video on square root functions.